Okay, so this lesson is on isosceles and equilateral triangles. So we've already talked about what those are on some level. An isosceles triangle is a triangle with two congruent sides. An equilateral triangle is a triangle that has all three sides congruent. Okay, so first let's talk in a little bit more depth what an isosceles triangle has. An isosceles triangle has two congruent sides, as we already know. But the isosceles triangle theorem says if those two sides are congruent, so congruent here and here, then the angles opposite those sides are also congruent. So this angle here and this side are opposite of each other. They're across from each other. And this side and this angle are across from each other. So because AB is congruent to BC, that also means that this is congruent to this. Okay, so really in this example, if two sides, in this case AB is congruent to, that's BC, then that means angle 2 is congruent to angle 3. That's all that's saying. So I don't know if you need to write this whole thing in here. Sometimes this picture is a little bit easier to understand. But there's both of them just in case. Okay, the converse of that says, let's say you got a triangle and you know that this angle and this angle are congruent, then that means the sides across from them have to be congruent, this one and this one. So just the reverse of that. So in other words, let's just say this is the same triangle, A, B, C. If angle A is congruent to angle C, then that means AB, side AB has to be congruent to side CB. Again, the picture might make more sense. Okay. Equilateral triangles, same thing. We already know that in an equilateral triangle, all three sides are congruent. But we know that an equilateral triangle is also an equiangular triangle. So we have already talked about that. If it's equilateral, it's automatically equiangular. So that means this angle, and this angle all have to be congruent. We also discussed that since a triangle has 180 degrees and all three angles are congruent, that means 180 divided by 3 is 60. So that means this has to be 60 degrees, this has to be 60 degrees, and 60 degrees. So an equilateral triangle, all the sides will be the same, and all the angles are congruent, which means 60 degrees. So this part down here, I think, is unnecessary. So we don't even need to really talk about that. Just make sure that you know this, and then you're good. Okay, so now we're just going to put that into practice. So here there's a couple different examples, some isosceles, some equilateral. Okay, so let's take a look at number 1. Number 1 says that I have triangle JKL, and they want us to know what angle J is and what angle K is. Well, since it's isosceles, we know the sides and the angles across from each other should be congruent. So these two are across from each other, and these two are across from each other. Since the two sides are congruent, that means this angle and this angle have to be congruent. So that means J has to be 68 degrees. Okay, so cool. Now we have K left over, so we're just going to go 68 plus 68, which would give us 136. So if I go 180 minus 136, that tells me that the last angle has to be 44 degrees. Okay, and that's just using the stuff we know about triangles and isosceles triangles. Okay, number 2. It's isosceles again. This time, that side and this side are congruent, and then the angles across from them would be C and E. So that means this has to be congruent to this. Well, a triangle has to add up to 180. So if we say 180 minus 106, we get 74. Okay, so then if I take 74 and divide that by 2, that's 37. I'm dividing it by 2 because they have to be the same. So that means both of these are 37 degrees. Okay, cool. All right, number 3. The 2 angles are congruent. So that means these 2 sides across from them have to be congruent. So YZ is 12 centimeters. And then angle Y, we'd have to figure out what that is. So we could just go 77 plus 77. And we get 154 and take that away from 180. So 180 minus 154 would be 26. So 26 degrees. So that last angle here has to be 26 degrees. All right. Okay, let's take a look at this. Okay, so now I see that this angle and this angle are 60. So that means this last one has to also be 60 because it has to add up to 180, which means all 3 angles are the same. It's equiangular, which also means all 3 sides have to be the same. Okay, so now I know that angle C is 60 degrees. That means BC is also 9 feet, since they all have to be the same, and so is AC. Okay, that wasn't too bad. All right, now let's do one more here. Okay, this one, equilateral, which means all the angles are the same, and that means they all have to be 60. And they only ask for angles here on this one, so this one's kind of easy. We know these are all the same, which means they all have to be 60 degrees. So 60, 60, and 60. All right, that was easy enough. All right, so then the only thing that they can really do is just try to throw a curveball in there by throwing in some variables. So don't let that fool you. Just be ready for it and you'll be all right. Okay, so this is an isosceles triangle. The 2 sides are congruent, which means then that this angle and this angle have to be the same. So we're gonna set them equal to each other and solve. So let's see. 4x plus 7 is equal to 9x minus 33. All right, now we just need to solve that. That's kind of hard to read. Let's fix that. Okay, so I'm going to subtract 4x from both sides. We get 7 equals 5x minus 33. All right, and then add 33 to both sides. We got 40 equals 5x. And then if I divide this by 5, I get x is equal to 8. And then just double check, it says solve for x, so we don't need to plug anything in there. X equals 8 is my answer. Okay. let's take a look at this one. So these two angles are the same, which means the sides across for them have to be the same as well. So this and this have to be equal to each other. So this is an isosceles triangle again. So in this case, 15x plus 7 has to be equal to 23x minus 17. And then get all your x's on one side to solve. We got 7 equals 8x minus 17. Add 17. We got 24 equals 8x. And then divide by 8 on both sides. So we're going to get 3. Okay. And again, we're solving for x, and that's it. All right, last one is an equilateral triangle. It tells us that, and we need to solve for x and y. So, all right, well, one thing you know is it's equilateral, which makes it equiangular. All of these are the same, which also means this has to be 60 degrees. So we couldn't start out by saying 7x minus 3 has to be equal to 60 and solve for x. So add 3. 7x equals 63. And then divide by 7, and so x is 9. All right, well, that wasn't too bad. Then you just want to pick another thing to do. It's equilateral, so we know that all three sides are the same. I'm gonna, whoops. There we go. We're just gonna say, I'll pick any two sides. So I'm gonna do QP and QR and set them equal to each other. So that's 14y minus 59 is equal to 9y plus 1. Get my y's on one side. So I have 5y minus 59 equals 1. Add 59 to both sides. So 5y is equal to 60. And then lastly, divide by 5. So y equals 12. So I got y, I've got x, I'm done. So it's just expanding on our knowledge of what we already knew about isosceles and equilateral triangles. And that's it. All right, hopefully this makes sense. Do this assignment. Good luck. Bye.